Hello viewers, welcome back. In the last lectures we have discussed various substitution reactions like SN2, SN1 and the factors affecting both the rate of SN2, SN1 reactions followed by the stereochemical outcome of SN2 and SN1 reactions. And before going into this detailed the topic of this today's lecture, we just summarize or just remember or recollect the SN1 reaction that is going to helpful for further understanding for the present lecture. Okay. So this is the tertiary alkyl halide. As we know, the first step will be the slow step, and so this is the slow one. Okay, because the carbocation formation is slow and this nucleophile attacked the carbocation and we get the substitution product by the SN1 pathway. Now this carbocation intermediate may stabilize some other pathway, and that I am going to discuss and I tell you in the reaction mechanism, and it gives some other product, that is elimination product. So this like alkene. Okay, so this is another pathway how this carbocation is getting stabilized to get a different product. This is the elimination product, and here this is the substitution product. Here the carbocation is a common intermediate. That means this can give both the products, but you should see carefully. But in this condition there is a heat. Okay, you see this is the heat is required to get this product. Now we see the reaction mechanism. This, as we learned in the SN1 reaction, the first step is the formation of carbocation. Instead of this nucleophile attacks this positive charge carbon, what it will do is this solvent will abstract the hydrogen from the beta carbon. You see, halogen connected carbon is a alpha carbon, the next carbon is the beta carbon. So you see, this is the beta carbon, this also a beta carbon, and this also a beta carbon. So the solvent which is going to act as a base, so it may accept the hydrogen from any of the beta carbon. Here all the methyls are same. Okay, all the beta carbons are same, that's why I took only one possibility. So it abstracts the proton, then followed by there is a change, this bond get cleaved and this comes as a double bond. So we get this one as a alkene product. Okay, CH2 like this plus H3O. This is the complete reaction mechanism. Now the rate of reaction is, as we discussed in the SN1 reaction, if the carbocation is not formed, the base will not abstract this proton. That means the rate of reaction is completely depend on the formation of carbocation. So that means from the tertiary alkyl halide. Okay, so that means this reaction is depends on only one reactant. So why this is called as E1 reaction. E1 means 1 stands for unimolecular and E stands for elimination. So we call it as a unimolecular elimination reaction. Okay, so this is the overview of and reaction mechanism of E1 reaction. Now let us see, if I take this is the different substitution of the beta carbons. You see, here in all the case are methyl, so why we get only one product. Suppose if our beta carbons are different, you see all the beta carbons are different, in this case what will form? As we know, the first step is the formation of carbocation that I shown here. So what will happen is this carbocation, you see, this may abstract the proton from any of this beta carbon, you see. So this is the one beta carbon, and this is the another beta carbon, and this is the third one. Okay, we are having three different. Now if this is getting abstracted by this one, and this will come like this, I put this is the pathway A. Okay, so then what we will get? So we will get this one, see, like this we will get. So this is the one, CH2 CH3. Okay, so this is the product A, I can mention it. Okay, if suppose this is the another one, this is the beta, another beta carbon, so I put this is one. If this one abstract like this, so what will happen? So it goes like this, give like this. So we can get by this one, see. So this CH3, this one CH, and CH3. Okay, this is the product B. And if I show this one, suppose this one is the another beta carbon, if it attacks this beta carbon hydrogen, what will happen? So by this one, this pathway I will mark it as a C, and this will come like this. So, and we will get this is the pathway C, I will mention it. So like this, CH2, this is CH2 CH3. Okay, now so we get three different products. You see here, this is the A and B, and this is the C. Now the product distribution will be varied. Please listen carefully. Whenever we get the highly substituted alkene, so this product is called as Setsev product. Okay, so this will always be a major one. So the Setsev product will be always major one, and the least substituted alkene will be called as a Hoffman product. Okay, so this is always minor. Understand it? That highly substituted alkene, this is major product, and the least substituted is a minor one, and this is the second maximum, or you can call it the second major one. Okay, so if your beta carbon is having a different environment, then we will get a mixture of products. That is the nature of E1 reaction. Also, one more thing we should remember, in the SN1 reaction we learned it may give the rearrangement product. So this is the default rule. We should always remember, whenever there is a carbocation, so there is a possibility of a rearrangement. Okay, now you see this will go like this. So this is a secondary alkyl halide. Now this form this carbocation, and so this is one. Now there is a possibility of migration of this methyl group to here to get this tertiary carbocation. Now this is a tertiary carbocation. So this will be the most stable. So why this will get migrate. Now next step is elimination, okay, of the proton. So what it will do, so here this hydrogen will get eliminated to give the most substituted alkene, and this could be the major product, okay. So please remember, so here also wherever the carbocation formation there is a rearrangement, okay, that we should remember either in substitution or in elimination. Anywhere there is a possibility of a rearrangement, that we should not forget it, okay. So in summary, so the carbocation is formed, later the base which will abstract the proton from the beta carbon and it gives the elimination product. If there is a different environment of beta carbon, we will get various or mixture of elimination products. Among that, Setsev will be the major product. Setsev product is highly substituted alkene, okay, and the Hoffman is the least substituted alkene, followed by there is a rearrangement. So this is I shown the example, this reaction, okay. I hope you understand. So we will discuss another reaction in the next class. If you like this video lecture and it is useful, please subscribe and share it. Thank you very much.